Okay, I'm no expert on automatic transmissions, but I know how they work. Back in March of this year, I posted a video of a split open torque converter to show how an automatic transmission works with no clutch, how oil pushes everything around an automatic transmission, how it has such smooth takeoffs. That's what a torque converter does. Well, this car has a torque converter too, or the transmission that came off. I have that all still in one piece. But now I have the whole transmission disassembled so I can explain how it works. It has two different kinds of clutches inside. It has band clutches and wet clutches like motorcycle clutches. And it has a planetary gear system. That means the gears are always meshed. Depends which housing you clamp with a band like a brake and hold the housing, or which plate you push with a clutch like on a motorcycle clutch. That's how it selects its speeds. It never engages gears. That's why it's such a smooth feeling, you never hear a grind. All the gears are always engaged in a planetary gear system. So now I'll try to explain that. So first of all, you have the case or housing or body of the transmission, as you want to call it. Then the business end is the torque converter. That bolts to the flywheel of your car. So that's what the torque converter looks like in the normal position in a car, horizontal. Those are the bolts that go to the thin flywheel. The torque converter is full of oil, and it actually acts like the flywheel in the car that keeps all the parts moving around in your engine. Now, this is the front input side of your transmission. This is called your front torque converter seal, which seals around there. And if your transmission leaks oil, and the oil is coming out of the bell housing dripping underneath, that's likely the seal that needs changed. Unfortunately, you have to take your whole transmission off the car to do that. So this part is the first part you see inside the bell housing of your transmission, all bolted into that hole. This shaft is actually a stationary shaft, and it holds one of the sets of spinning cups in there, stationary. There's what the opposite side looks like, and these little pads are part of a piston system. They move out this way by oil pressure behind them to actuate a clutch. I'll show you what I mean. This is the next part inside the transmission that goes on to here. Here we have a wet clutch, a metal friction disc, and a fibrous friction disc, not made out of metal, made out of something like the stuff on a brake pad. It probably will snap. Well, actually it didn't snap, it's got a little bit of aluminum in the middle. But it does work like a brake pad. Well, there's a whole bunch of them here. So what happens is, when the transmission wants to go to a certain gear, these aluminum pads, all three of them, move out just a little bit. And they push on this clutch, and they squeeze all the plates together. And that causes a certain part of this rotating part to engage. Now we have in automatic transmission clutches and brakes. They sort of work the same way. This is called a band brake. Goes around this smooth housing, and when it gets squeezed together, it stops that part from spinning, and it's got brake friction material on it too. So when it's necessary for this transmission to change a gear and it needs to brake this rotating cylinder, one bump is affixed to the housing of the case, so it's stationary, and one of these pistons, this goes in a little cylinder I'll show you in a minute, one of these pistons, that's the actuator pin, pushes on this band brake and clamps it, and it stops all this from turning. So that's how that gear is shifted. This is a 4-speed automatic. Now in the back here is another wet clutch, just like a motorcycle. Friction material, drive plate, so on and so on. When your automatic transmission wears out, it's not the gears that wear out, it's either the bushings in here, rubber O-rings and seals, or the friction material on these plates. That's how you get such smooth shifts in an automatic. There is no gears engaging. It's always these brakes or these clutches just being squeezed together to shift gears. Now this is the input shaft. Get all this out of the way. The way this was assembled was like this. And that went through there. So this is the input of your transmission. This is the oil pump drive shaft. The torque converter always needs oil pumped into it, because if there isn't oil pumped into it, gravity causes it to leak halfway down to the middle and it runs back into the oil pan of the transmission. So as soon as you start your car up, it's rotating this shaft, pumping oil through the spaces around here to keep your torque converter always full of automatic transmission oil. This is a stationary shaft. It just stays in this position all the time, affixed to the transmission. And this shaft is the input shaft where all the power from your engine, from the inside part of the spinning torque converter, which is like the clutch, drives all these clutches and everything and gears inside. On this particular transmission, there's another clutch in here, and if you notice, the metal's all black and burnt looking. This is a bad transmission, even though the rest of the transmission is good, because the clutch pack in here is burned out. The friction material got burned off, and the reason it got burned off is because it had low oil in the transmission, and the person was revving it because there was a transmission leak, and that causes not enough pressure to engage the clutch, and that caused the clutch to slip when he was revving it hard, and that burnt out all the plates in here. Just like I said before, when automatic transmissions go bad, it's these clutch plates or O-rings that wear out, or bushings between all these cylinders. This is the final output of the transmission. This goes to your drive shaft. That worm cut gear, or helical cut gear, is for the worm drive for the speedometer pickup. Inside there is a little plastic gear that rides on those gears, and that's where you hook your speedometer cable to. All these notches back here is the thing that goes click, 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 click when you put your car into park. And this little actuator arm or lever grabs one of those notches, and that's park on your car. That's all that holds your car. So if you put your car into park while it's still moving, this goes click, 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 click through all those little bumps. Now this is the business area of the transmission. That's called your planetary gear system. It's kind of hard to show. It also has another braking clutch here, and another piston that actuates it. So what happens when it wants to change a certain gear, all this clamps together, and it's pushed by this piston and hydraulic pressure to clamp like that. Show you what's inside. That's your planetary gear system. And inside here, that drives it, is a main gear. And another one. And you can see inside. So by a combination of which housing you're turning, which housing you're clamping, and which one of those two sets of drive gears on the inside is spinning, gives you all your different speeds. And then the power is transmitted to the outside of these gear teeth to that housing here. And then it comes out the final drive. So these gears are always constantly engaged. That's why you never hear a grind or a clunk or a shift. It's just the bands and the clutches changing what combination these are spinning in, so that they'll send different speeds to the back of your transmission.